Hi all. So last time we have noticed how the network cable works and how we can connect the network cable and how we can test the connections are correct or not with the RJ45 connectors and everything. Okay. I hope you have viewed the other videos I have heard in the descriptions. Just go and have it. So now let's see how a company's network is built. Generally, company to company, the designs could differ. Network architecture could be differing. But the thing is, the basics will never change. So, which in case, I'll just show you the file which I made. So you can see in the screen the basic network architecture of a company. Okay. So here you can see PCs are connected to network switches, and network switches again going to the switches and host switch and routers, etc. You can see which I have marked in the rectangular section. The basic architecture is not going to differ. It's going to be the same for all companies. Okay. So when we have PCs or laptops or like end devices, we can call it. Okay. Your PCs, laptops, or phones, or whatever, printers. etc. Okay. So all these are considered as a edge device. Okay. End device. So these are basically connected to the network switches, which are located in the hub room or network room on each floor. Let's consider this is the first floor or second floor. So imagine on each and every device which you have in your company, like PCs, okay, everything is connected individually by a network cable, which goes directly to a network switch port. Okay, so you can't connect two, three devices into one. So if you have a computer, it should directly connect to another network switch. Okay. Just port. You can see here, if you have the physical view, you can see generally in uh, the desktop and you can see the network card and port. So in case if you take a laptop, you can view the network port over here. Okay. Then let me show you the switches. This is basically a 2960 switch, so, so which is already end of life, which means like now just we are not using. Basically, we use 9300 series or 3650. Okay, so these switches generate. This is for example on I have just shown. Okay, so you can see it has many network ports. So this is a 24 port network switch. So each device, if you have 24 devices in your company, you can connect each one to each port. And you can see where I'm pointing is the fiber port or mostly SFP. So via the SFP, we'll connect a fiber cable and I'll explain those things later. So actually, from switch to switch, when we want to connect like first floor to second floor, uh, or data center like that, to connect it to the host switch, we are using this SFP, which I'm just explaining in a brief only. So you can leave it for now. Just remember this network ports only, which I'm explaining now. You need to connect each device via network cable to this. Okay. If you are in first, all the let's say 10 PCs are there in your first row. Okay. So first row will have probably a network room or and there you can find switch stacks. Okay. Switch stack in the sense there won't be only one switch will be connected. Like we will stack a bunch of switches, like 4, 5 switches, which is called the switch stack. Okay. So because in each row you will have like hundreds of PCs, laptops, etc. Printers. So each switch will have maximum like 4 or 48 ports. So where do you connect the remaining? That's the reason we are connecting separate switches and combining them, stacking them. So from now, after here, I hope you'll be clear. Okay? So the end devices are being connected. Let's say in your desk, there will be network port. You will connect your laptop there, and that network port internally connects to these switches in the control. In our example, it's like first row. Okay. So from here, after this, you can see first row switch, second row switch, like that I have mentioned. So these are called access layer. Okay, in theoretical, which is end devices are directly connected to access layer switches. Okay, from there, from the access layer switches, from switches it goes to next step. You can consider it as directly going to core switch or else to another switch. Okay, these are redundant purpose. Okay, so individually, let's say first row, second row, third row having switch three switches. Okay. From there, if there's a data center or common core switch, these switches connects directly to the core switch here. This is the switch I'm talking about, which is the core switch. So access layer switches, we are connecting directly to a core switch. Or in mid, you can add a distribution layer like the switches in mid. Okay. So on the core switch, what happens? Like from this access layer switches, you will send fiber connections mostly. Ethernet is also possible. I'm not saying it can't be. But the thing is mainly for speed. Okay. End device to access layer individually, just the device is connected, right? So the current speed we are not considering and calculating the cost and all. We are just using Ethernet cables. You can see these connections. So these are Ethernet cables. In our last video, we have watched 6 and all. So these are the cables. Okay. So after that, from the access layer, which you can see as I have already showed the SFP. Here, this we can consider as SFP modules. Okay, which I will explain later in a separate video. So from this SFP module, there's a small piece of module. From that, you can connect your fiber cables. Okay, I will have to explain you about fiber also. So for now, just imagine a fast connection which is made by like laser. Okay, optical. Okay, so that's how the data transfers. Okay, so from this SFP, a fiber cable is going directly to our host switch. Okay, so now why we are using the fiber? Because from let's say entire traffic, network traffic from your first floor, second floor, everything is transferred to your core switch. Okay, so let's for example, if you take first floor, the entire first floor traffic need to be transferred to the core switch. Right? So we might need a solid fast connection. So for that, we are using a fiber. Okay. So fiber cable is connected to the core switch SFP module, and we will be making the connections and data will be transferred. So from the core switch, before that, core switch generally, let's say I have used like 9500 Cisco, right? So access layer we use generally like 9300 or 3650 series. There are many. We can refer Cisco website that. And core switch I have used 9500 split. Okay, 9500 series. And from the core switch, it could go to the router or firewall, whatever. That is the thing which I mentioned earlier. Company to company differ slightly, like, because based on your company network policies and security reasons, whether from the core switch they could transfer it to a firewall, or else they could transfer it to a router. Meraki firewall sometimes it's connecting from core switch. So likewise, okay. From router, let's say in this example, I have made a router connection. Core switch. From router, this is the company's image. Okay. Outside. From the router, it's going to reach outside the company, which means the ISP, Internet Service Provider, is going, which I have showed like the route. Okay. So, for example, generally AT&T networks or Bridge Connects, these are some foreign ISP connections. Okay. So, these things can be connected. So, up to this level, you're not going to learn now. Okay? These are about routing and all we will check. Okay. So by now, you just need to know the basics. And when you join a company, how the network is going in and out. So just try to understand this concept. Mainly, your access layer devices are transferring, uh, which means the net access switches are connecting to the core switch and core switch to router and router to ISPs. Okay. So you might see there are different, what do you call, cable connections, and from switch to switch you can see here there are two cables that are, these are for redundant purposes, okay, which I will explain later, or if you want, this is for redundancy in the sense, let's say if one cable got uh, damaged or interrupted or some issue, you can use the data will transfer to the via the other cable, okay, so there won't be any network block, okay? So there won't be a network downtime or something. So you can easily work and continue your process. Okay, so that's the reason the redundancy is maintained. And you can see here, other than the access switches, you can see there are two core switches, two routers, right, and two ISPs connected. So all these are due to maintain the redundancy. Okay, so just for example, if one cable or one device goes damaged or any issue or down, so to avoid the downtime, the traffic passes through the other net. So this is what happening here. You can just imagine now. I hope you will have a brief idea how a company's network works now. Okay. So you can see here from the distribution ASA, I have showed two cable connections from switch to switch. So this is basically Ethernet connection. Okay. Later down the road, we'll be learning these things specifically. Okay. And you can see some uh, port status are showing green and some are shown as orange. So also there's a reason for that. And the port states is indicated. Okay. So I will explain these things later in a separate video because it consumes more of it. Okay. It's not a short thing. Okay. So uh, actually, in brief, if I explain, you won't be having much idea about these things. Okay. So later, uh, in our next video, we'll be having another topic. So far, you can just have an idea and just go through the previous video and have an